In this experiment, we are going to do the quality control of a vinegar sample. Vinegar is a solution of acetic acid in water. From theory, you may remember that we went through one kind of chemical reactions that are called acid-base reactions, where an acid reacts with a base to give salt and water. In this reaction, when all the base consumes all the acid, the only thing we will have in the solution is the salt and the water, and the acidity of the solution will go from an acid solution at the beginning to a neutral solution. When we do that, if we put an indicator in the solution, which is a substance that changes color, there is going to be a very abrupt change in color that will indicate that the amount of acid and the amount of base stoichiometrically are going to be the same, which means that the moles of acid are going to be equal to the moles of base at that particular point, where the indicator or the dye changes color. Therefore, when the base consumes all the acid in the vinegar sample, we're going to have that the number of moles of acid is going to be equal to the number of moles of base. If we know the molarity of the base, which is the number of moles of base that we have per liter of solution, and we multiply it by its volume that we can determine experimentally, that's going to be equal to the molarity of the acid times the volume of the acid, which we also measure experimentally. So by knowing the molarity of the base, the volume of the base, and the volume of the acid used in the experiment, we can calculate the molarity of the acid. Now, the idea of the experiment itself is to determine as precisely as possible the moment when the number of moles of acid is equal to the number of moles of base. And that's called a titration. And that's what we're going to be doing in this experiment. So in this experiment, we're going to determine the molarity of the acetic acid sample as molarity of the sodium hydroxide times the volume of sodium hydroxide divided by the volume of the acetic acid that we use. Now, since the quality of vinegar is given in percentage of acetic acid, that's what we see in the bottle of the product, we're going to determine the percentage of acetic acid in the sample that is being given to us in this laboratory. To do that, we need to know that the moles of acetic acid that are contained in the portion of the sample that we use to do the titration is equal to the molarity of the sodium hydroxide times the volume of the sodium hydroxide. After we calculate those moles of acetic acid contained on that sample portion, then the mass of acetic acid of that portion is going to be equal to the moles of acetic acid times the molar mass of acetic acid, which is 60 grams per mole. After we have that number, then the percentage of acetic acid is going to be equal to the mass of the acetic acid calculated before, divided by the mass of the sample times 100. For this experiment, we are going to need a 50 milliliter burette with the burette stand, 3 Erlenmeyers. This funnel, which is used to fill up the burette, beakers, a 5 milliliters volumetric pipette, the pipette filler, a sodium hydroxide solution of a known concentration. This is called a standard solution. In this case, the concentration is 0.08526 molar, and we are going to write down that number in our report. You're going to find the vinegar solution. This is the sample in which we're going to do the quality control. And finally, we have the phenolphthalein, which is the indicator that is going to show us when the moles of acid are the same as the moles of base, which means at the point where the sodium hydroxide has consumed all the acid in the solution. First, we are going to fill up the burette with the sodium hydroxide. So the sodium hydroxide is going to be in the burette, and we are going to pour it down into the acetic acid solution, which is going to be in the Erlenmeyer. Before we fill up the burette completely, we have to condition it. Conditioning means that the concentration of the solutions needs to be kept constant at all the time. So if we empty the burette and there is some water residue in the burette, when we put the sodium hydroxide solution, the sodium hydroxide solution is going to be diluted with the water that is in the burette. In order to avoid that, we use small portions of sodium hydroxide and let it pass through the walls of the burette to rinse out any residual water that may stay on it. See that we have emptied the burette. It was filled with water at the beginning, okay? So we make sure that all the water is drained out. And now we pour sodium hydroxide in a beaker. It's always a good idea to tilt the bottle up and down a few times to ensure that the solution is homogeneous. Using the funnel, now we're going to pour a little bit of sodium hydroxide on the burette. See, it doesn't have to be much, just a few milliliters. And then turn the burette in such a way that the solution touches all the walls of the burette. Once that is done, we drain it out. Okay, and we can drain it from the bottom and also from the top. This operation needs to be repeated 3 times. That's what I'm going to do now. I'm not going to show it in the video, but you have to repeat it 3 times. Okay. Now we proceed to fill the burette completely with sodium hydroxide. Using the waste beaker, now you have to make sure that this section of the burette is completely filled. At this moment, it just has air on it. So open the valve until it's completely filled. And after it's completely filled, you have to take it down so that the volume reads exactly 0. Take a look of the meniscus and see that the burette at this moment is reading 0 milliliters. We are going to condition the pipette. For that, we pour a vinegar solution into a beaker and use a pipette filler. The pipette filler has 3 notches. One of them, when you press it, is to create the vacuum. Okay? And that keeps the air, keeps a vacuum on the filler. The second one is to absorb the solution, and the third one is to release it. So, let me do a little demonstration how it works. Don't push this too far in, okay? Just by pushing it a little bit is enough. So, we submerge the tip of the pipette in the solution and press this notch, okay? And now, if we want to discard it, we press this one. Right? At this moment, what we want to do is to condition the pipette. So we're gonna take a little volume, and what we're going to do is to take the filler out and rinse the pipette with the solution. And that needs to be done 3 times. So after we have touched the walls of the pipette with the liquid that we're going to be pipetting, in this case the vinegar, we drain it out on the waste. And after doing this 3 times, the pipette is ready to be used. Okay, now, in order to get the mass of the sample, because we're going to get an exact volume, which is 5 milliliters, but we also want to know the mass. In that particular case, what we're going to do is turn on the balance and weigh the empty Erlenmeyer. In this case, this Erlenmeyer weighs 83.41 grams. And we write that mass in our table, 8.2. Now we pipette 5 milliliters of sample. To do that, we use the filler, fill the pipette all the way up past this mark, okay, which is the one that is going to indicate that exactly we have 5 milliliters. So now we are going to drain a little bit of liquid carefully. And now the meniscus is exactly on the mark, which means that here we have exactly 5 milliliters of sample. And now, pressing the E notch, we pour the sample into the Erlenmeyer. At the end, we touch the wall of the Erlenmeyer with the sample, with the pipe, the tip of the pipette, and you see that there is a little bit of liquid left. Leave it there. It's counted for, okay? You don't have to drain it out. And now we write the weight of the Erlenmeyer plus the sample. So the mass of the sample, if they do the subtraction, is going to be exactly 5.00 grams, which is not surprising because that solution of vinegar or of acetic acid in water is basically a solution that has a density very close to 1. So 5 milliliters make up very close to 5 grams, and that's what we get experimentally. And the sample volume, don't forget about it, is going to be also 5.00 milliliters. Now that we have measured the exact volume of the sample, the molarity of the acetic acid, which is the sample, times that volume give me the moles of acetic acid that are here. So we already have the moles of acetic acid trapped on this Erlenmeyer. Okay? What we're going to do now is to put water in such a way that we increase the volume a little bit to make it easier to see a change in color. Next step is to put 2 drops of phenolphthalein, which is the indicator. When you put the phenolphthalein in acidic media is going to be colorless. And that you can see. And then now we have an initial volume of sodium hydroxide of 0 milliliters, which we have to write on our table with experimental data. We're going to keep this wash bottle at hand all the time, and we're going to start the titration. We can open the valve this way and keep stirring all the time, and you can see that when the sodium hydroxide drops in the solution, there is a pink color. Okay? So we're going to continue like that until we get close to what we believe is going to be the point where the moles of sodium hydroxide that we're pouring from the burette is going to be equal to the moles of acetic acid that I had at the beginning on the Erlenmeyer. And that's going to be when this solution turns from colorless to pink. As we get closer to the final point, you see that the pink color becomes more and more persistent. Okay? See? Now that we are close to the end point, a rapid turn on the valve of the burette will deliver about half a milliliter, or a drop. And here we continue adding bit by bit and stirring all the time until the pink color is persistent for about 10 seconds. Okay, and that's the end point. So, if we add a half a drop more, see what happens. You see? So the end point was the one before this drop. And that was the one that persisted for about 10 seconds. That's about 0.05 milliliters. So we're going to do that correction when we read the volume. We can see that the volume is in between the mark of 31.0 and 31.1. Which will mean that is 31.05. Now, since we said that we added an extra drop, the real final volume was 31.00 milliliters. And that's the number we're going to write on our table. Determine the volume of sodium hydroxide that was used is going to be the final volume in the burette minus the initial volume. Since the initial volume is 0, then the amount of sodium hydroxide used is going to be 31.00 milliliters. Next, we are going to fill up again the burette up to the 0 mark, because as you see, this is a 50 milliliter burette. If we try to do a titration with whatever is left here, we're going to need 30 milliliters and we only have 20 milliliters left. So at this point, it's a good idea to fill up the pipette again up to the mark, the 0 mark. After we have the burette filled up again, we're going to do another titration. And we're going to repeat the same procedure that we already went through in trial 1. And that's going to be done other 2 times. So at the end, we're going to have 3 trials. Okay. After we have completed the 3 trials, we got the table completely filled up and ready to perform the calculations that we need to perform in order to get the molarity and the percentage of acetic acid on the sample that was handed to us. We are going to perform an example of calculation. For the first trial, this is the molarity of the sodium hydroxide. This is the volume of sodium hydroxide that we use, and this is the volume of the sample that we pipetted into the Erlenmeyer. So the molarity of the acetic acid is going to be 0.5286 molar. To calculate the percentage now, first we calculate the number of moles of acetic acid that we had on our sample, and that's going to be the molarity times the volume, but make sure that the volume is in liters, which means that the 31.00 milliliters needs to be multiplied by 10 to the minus third. And then this number of moles of acetic acid is going to be multiplied by the molar mass of the acetic acid, which is 60, and divided by the mass of the sample, which is 5.00 grams. The result is 3.17%. This ends up this lab. Now you can complete your report and make sure that you have it done by the due date.